Okay, ankylosing means the frenulum, that is the thing underneath the frenulum, right? There's a line there. That will be shortened or twisted or whatever, and therefore you have the tongue will not be normally there. That's why it's called ankylosing. Okay. So there are two dominant forms are there. One with missing teeth, and the other one is with infertility and anosmia. Anosmia means inability to smell. But this disorder is caused by transcriptional factor deficiencies. Okay, these are TBX, and these are transcription factors. And also the fibroblast growth factor receptor, FGFR1, there is also a deficiency there. Okay, several transcription factors. And also in another syndrome called Vanderwood syndrome, okay. Now we come to congenital heart disorders. This is almost like 100 of the 48 out of 1,000, almost 100. Most of these congenital defects are due to flow lesions, like in the sense of how the blood goes through the heart, depending upon which chamber is affected. Sometimes the aorta, which is actually carrying the figure here. Yeah. For example, if you take a look at the top third one, it's called hypoplastic left heart. Okay, what's happening? Left ventricle is extremely small. It's hypoplastic. If you take a look at here, this aorta, there is aortic coarctation, there is constriction of the aorta. So the blood won't go through very well. It's a flow lesion. Same thing, if left ventricle is very small, flow lesion. Whereas in the other place, there is in the patent ductus arteriosus, okay? Usually what happens is that this ductus arteriosus, when you are developing, that will disappear. But now the ductus is constantly being connected. There is one aorta and the other vessels are being connected there. And that connection was important for embryonic development, but that is not good for the adult. And that still persists in the adults, and therefore there is called patent ductus arteriosus. And the blood flow will have a confusion about which way to go. And that is not good either. So these are all congenital flow abnormalities of the heart defects. Okay? So another multifactorial disorder is a mental illness. This is the one which is less characterized, and more research has to be put into this particular area. It's not really much known. We know that there are two major ones called schizophrenia and a bipolar disease. Young adults will have, a lot of them are schizophrenic or young adults. And of course, late adolescence is going to happen. And people think, this delusional thinking will be there, disordered mood and all those sort of characteristics which is schizophrenia. In this also, there's almost like 60% of monozygotic twin percentage. Therefore, some environment, but mostly genetic. Some disorders are, like for example, there's a Vela-Porter-Facial syndrome and all those things are associated with some schizophrenic disorder. But still, even though we know the deletion in the 22, we still don't know the genes which are linked to schizophrenia. Still need to be done. Bipolar is also called manic depression. Sometimes they feel grandiose, sometimes they feel depressed. So it's just alternating from one high mood to the low mood and so on. That is the manic depression. And also they have high dangerous risks, decreased interest in pleasurable activities. You don't dress well, you don't participate, comb your hair or whatever. Suicidal thinking, and these are all extreme cases of manic depression. That is the bipolar disorder. Okay? Here also monozygotic inheritance is 62%, but it's pretty strongly genetic. Unfortunately, nothing much is known about it. This is a major, very, very highly prevalent multifactorial, the coronary artery disease. 500,000 people die every year. Most of them are due to what is it called atherosclerosis. Just like Alzheimer's has a female bias, this has a male bias. Males are more affected in this particular disorder. There are other factors which are contributing to this are diabetes, hypertension, smoking, obesity, and all those things are risk factors. But what is atherosclerosis? Atherosclerosis is, it is a plaque formation within the vessels. As you know that the monocytes which are present in our bloodstream, they can go and seep through the endothelium. That is, they are just flowing in the blood. But all of a sudden, they just go through the endothelium. That is, they can pass through. And they enter the subendothelial area. And there are what are called foam cells. I don't think the slide has that information. There are what are called foam cells which will form underneath. And those foam cells, we don't know still the mechanism, but somehow that initiate what is it called, initially so-called white blood cells and everything else, and a little bit of the scar tissue will form in this area of the vessel. Now, somehow, there is what is it called, deposits of the fat and calcium and all those things will come and just inside the vessel, and they keep growing. That is called a plaque. The plaque can grow to the extent where the orifice of the vessel is going to be extremely narrow, like a couple of millimeters, even as a big vessel. And in particular, the plaques will form wherever there is a bifurcation of the vessel. That is, whenever there is a branching, somehow the flow also makes it extremely important for making the plaque to grow. But when the plaque ruptures, we don't know when the plaque will rupture. But if somebody can detect, hey, look, this is the time when plaque ruptures, you can treat them. But that's $1 million research program. Nobody still knows when the plaque will rupture. And the plaque can be there in the vessel, which is supplying the heart. And the plaque, if it ruptures, that's called myocardial infarction. But plaque rupture will immediately be followed by what is it called a thrombosis, because the plaque is loaded with a charged molecules, and therefore it is going to activate the tissue factor which is flowing in the bloodstream, and the tissue factor will activate factor 7, 7 will activate factor 10, 10 will activate prothrombin, generate a small amount of a thrombin, and thrombin will go back and activate factor 9, amplifying the cascade. 9 will again cleave more of a 10 and so on, and therefore you get more fibrin formation again, deposits a lot. So it is not only plaque formation, but in addition to that, plaque rupture would lead to the thrombosis, and that is why the disorder is devastating. Okay? This is a very common disorder. So the other genes which have been suggested which are high risk are anything to do with the LDL and HDL pathways. So again, angiotensin converting enzyme, that is ACE, is also one of the factors which are important for this disorder. They're all associated genes, ApoE, C3, LDL, okay, high LDL levels, and decreased HDL levels. These are all risk factors for that. And other factors like coagulation factors, there are much more, even if the plaque doesn't rupture, sometimes if it's a little bit more, you may get activation of that, because very small amount. After all, it is nothing but a balance. You have more factors, you're going to have more clotting. And therefore, it's a simple balance. Same thing with platelet factors, plasminogen activators, they're all related to coagulation cascade. pathways and arterial wall components and wide variety of other things are also risk factors for the coronary artery disease. So, I think we've finished the chapter, or is there something else? Yep. And there are also one more thing, slight variation. So atherosclerosis is nothing but a plaque which is not there. Arteriosclerosis, slight difference is there. There is more calcium deposits. Okay, it's hard and it is a hard plaque is an arteriosclerosis. Atherosclerosis is a soft plaque. Okay. So we continue with the next one, or do you think we will stop here? Stop here and go to the next chapter in the next class?
Yeah.